Hello guys, so today actually I will continue teaching the brake system chapter. So as I explained in the last part of the chapter, part 1, part 2, part 1, I explained the type of the brake system. Just you must just focus on it, don't disturb and find another problem. And the part 2 video was about the type 1 question, and I answered the question with all the steps, and also I explain and I show clearly the equation, the sample, the converting part, and all these stuff. So today actually we'll continue for the second part of the question on the brake system. It is the incline time. Just guys focus, incline time. Maybe you will face it. Maybe you will face this problem in the final exam. The inclined part. So the inclined part, first of all, actually I will put this question in the description in YouTube below the video. So first of all, guys, when you face any brake system problem, you're supposed to follow these steps. If you didn't follow these steps, you will get 0. So the first step of solving brake system part, first of all, specify your fixed point. Definitely the fixed point to be given in the question, to be written question, or maybe you're supposed to find it. So the second step is to set the forces. You're supposed to set the force, the FT and the FT and the Rn. So the third part, checking for R theta for n dash equal n or n dash does not equal n. So as I explained the last chapter, the last video, supposed to check the n dash, because most of the students forgot these steps, because the m dash, the coefficient of rank, is given on the question. So they thought that it is the original m that they can use. No, you're supposed to check before. You're supposed to distinguish between the m dash and the m with the specific angle of contact. You check angle of contact. If it was bigger than 60, so m dash does not equal the n. You're supposed to have the equation for the m dash. If it was the 2 theta less than 60, to be equal. So the last part, think most at the fixed point. So let's go for our side of our question. So inclined part. He given the n, the kilogram. He gave me the diameter. He gave me the radius, and he gave me the number of rotation, RPM, number of rotation. He gave me the force, and he gave me m dash 0.4. First of all, what? Fixed point. Part A here. Point A is the fixed point specified on the question and on the problem. It is fixed point. Here is the fixed point. A. Fixed point. Great. So the second thing, set the forces. The force, actually, you're supposed to set the forces. The dome rotates like clockwise. So clockwise, the FT to be right here, and the vertical, the Rn and the FT. Great. So the third step, checking for R theta, for n, for coefficient of fraction. The coefficient of fraction gave me 0.4. Great. It is n. It's always given by m, not m dash. Okay, n 0.4. Okay. Let us think. What's the angle? The angle given in the R theta that given was 30 degree. So 30 degree is less than 60. So R theta less than 60. So m equal m dash. I don't have to do the formula. So great. I passed the fixed point, set force, checking, and I have the last thing, taking the moment. Great. So I passed 3 steps. So what is required from the question? He wants the torque, the TB. He wants the number of revolution on the dome, the turns, small n. He wants the revolution means the small n, the turns, and he wants the time specific for the dome. Great. So first of all, this part, this is a tricky a question actually, the incline, because I have the angle, so the distance, the vertical distance for the moment to be changed. Just guys focus. First of all, the last part, taking the moment in the fixed point. Great, come on. When I take the fixed the moment in the fixed point to get the Rn and the Ft and so on. Great. So please guys focus. The DARM actually, the original place was here in the horizontal line. Great. The force and everything was in the horizontal line, but there was angle that make the DARM and the brake inclined with 30 degree. The 30 degree was here, there 30 degree inclined. Great. So بتقابل بالراس I have the angle here 30 also. So 30 30 تقابل بالراس. Okay, 30 degree I have. Great, great. I have 30 degree here, and here was the horizontal line, but it is inclined with 30 degree. Tamam. Okay, great. So now I'm supposed to take the moment at point A. Just focus please guys. So first of all, I have the force here 600 Newton. Tamam. I start with whatever I have, Ft force, Rn force, and the P given 600 Newton. Great. So first of all, when I take the moment for this force in point A, I notice that the force has some angle, so I cannot take just the vertical distance. I'm supposed to have some angle with this force because it is not like a horizontal or vertical force. It is half inclined, some angle there is. It's inclined, so there is some angle in this force. So how can I find this angle? How can I find this angle? It is 30 degree. Great, come on. So the distance, the vertical distance for this force, because I take the moment, it is 0.4 and 0.8 plus I get 1.4 meter. That's okay, easy. That's the distance between A and this force. Great, come on. So the second part, it is I suppose have angle. Okay, I have angle 30 degree, but it is cosine or sine. Okay, here actually you're supposed to use your mechanical engineering skills. You're supposed to have some sense of this engineering sense for this angle. So guys, the original force was in the horizontal line. Okay, was on the horizontal line, and I take the distance on the horizontal line. Okay, the original was horizontal, but it is inclined with 30 degree. Tamam, great. So this specific 30 degree actually, I take it cosine or sine for this force. So just notice with me. The 30 degree is close by the what? By the vertical distance. The vertical distance was here and inclined here. Was here and inclined here. So the 30 degree is close by this distance. If it was close by the vertical distance for this force, okay, the original was here and inclined here, the 30 degree was close by the vertical distance for the force, I take cosine. If it was far away from this vertical distance, for example, if the angle wasn't here, if the angle was here, and I'm supposed to take this angle here, great. So it will be far from the vertical distance for this force. It will be sine. If I shift the angle here, great. If I shift the angle here, it would be sine. But the angle actually was here. تغابر رأس سواء كان زاوية قريبة كوساين بعيدة ساين. Okay. Now actually very clear. I just teaching and I have style and teaching skills that all the students can absorb it in very easy and valuable way. تمام? Okay. I take the moment here. So the Rn, I take the moment, guys, and I have this 0.4. Why the Rn and the Ft there is no angle? Because it is vertical and vertical. There is no inclined for Ft or N, but the force has inclined. The force have some incline. That's why I take the angle. But the FT and RN, and I don't take angle because it's vertical and horizontal. Great, come on. Notice this here there is a trick. I cannot get the FT by the moment. Why? Because it is at the same line. At the same line, it's aligned with the point A, the moment, because the FT it's aligned with the moment. So I cannot take the moment to be 0. I cannot get the FT on the moment. So to be 0, FT on the moment, I get 0. I cannot get the FT from the moment because it's aligned with the point A. I cannot. It's actually basic one mechanical material. It's very, very easy stuff on the moment. Great. So at the moment, I take everything in the moment. I have the force here. It's minus 600 cosine 13 multiplied by 1.2 plus Rn times 0.4. Actually, I have just one unknown, so it's easy to get the Rn. I get the Rn was 1560, and I can now I can get the FT, the tangential force. I can get through the formula. I cannot get it. I cannot get it from the focus, guys. I cannot get it from the moment. Great. The FT equal, and I got the FT, and I got 624. Great. So he required from me the TB, the torque. The torque equal FT times R, radius. He gave me the diameter. I divide by 2, and I have the FT, and I got the torque. So here we come, guys. Here also the tricky part on the second question. He wants the number of revolution, the number of turns, the small n. Guys, the small n, if he required from me the small n directly, I apply this formula without any thinking, just fast away. Apply this formula. One touch play. على طول حط القانون هذا، لا تفكر، على طول القانون هذا، لا تدينا. Every number of revolution turns in. هذا القانون انتهى. Work done equal kinetic energy. Work done equal kinetic energy if he required for me the number of revolution, the turn small n. تمام. The work done equal the TB times by 2 by n. He wants this small n equal half mv squared. Great, guys. I don't have the v. He didn't provide me and give me the velocity. Okay, the velocity here it will change for the angular velocity. Why it would be the angular velocity? Because he gave me the rotation in RPM. He gave me the RPM, not meter over second velocity or something else. He gave me the RPM, so I'm supposed to have angular velocity, not the velocity with meter over second. I'm supposed to have the angular velocity. The angular velocity, why? Because it gave me the n capital rotation RPM. Great. So the angular velocity equal by multiplies d multiplies n the rotation square over 60, and easy peasy. I got the kinetic energy. Okay, kinetic energy equal what? Half m given v angular velocity. This is the formula. I got the kinetic energy. He wants the work done. The work done equal TV. I have TV. I have 2. I have 2 by. I don't have the small n. When I multiplied, I got this number with one unknown n. Great, guys. He wants the n. the n small. Very easy. بس شوف خطوات. One touch play. لا تفكر ولا تغوص. Come on, guys. Sorry for erase that part because I want to continue. Okay, let's focus. Okay, now he wants the number of n. Okay, I have everything here. So, what? Work done equal kinetic energy. Kinetic energy. Come on. Work done. I have I got 168. Half. Okay, you multiply everything what I get. the work done. All the work done, if I multiply and do these mathematics stuff, you will get 1016 in the small times 502 times 10 to the power 3. So you have everything. خلاص, just one unknown n. You get the n equal a number of revolution or number of turns. You get n 474 turns or revolutions or what else. And then خلاص. Hey, the last I got the TB, I got the number of revolution, I want the time. Best time for sure, very easy peasy. The time equal small n over big N. The small is turn, the turns or revolution, and the big N is the rotation. Small 7, 474, 200, and I got the time. By the time I will get it on the minute. I got the time on the minute, be 0.2 minute. I convert it to second, whatever, 60, and done. And I hope actually this part, the inclined, was very easy and clear and easy, and I hope you feel comfortable while you see this video. And actually I will provide the question in the description to be more clear. Thank you very much. See you there. Actually I explained now 3 parts of brake system. The last part I will explain, the last question is the double arm. Thank you very much. See you.